the way that the guided study groups are going to work basically is that I will go ahead and review the different topics that we had for the week. And then we will go on and do some review questions. And then afterwards, we'll finish up with any other question that you guys have. And we'll go from there then. So like I said, if you could just put your Penn State email into the chat box for me. You guys are more than welcome to ask clarifying questions throughout. Any specific questions, just hold till the end so that we could keep moving for everyone else in the session. And yeah, and feel free to use your microphone and your camera. You know, sometimes it's easier to type than doing that. So go ahead and let me know if that's easier for you guys. You're more than welcome to do that. All right, so let's get started with our first chapter. We talked about cases and variables here. So this is kind of the basis of statistics, okay? So cases are basically the studies that we use to collect our information, so the actual study itself. And then this is where, so we also call them units or experimental units because these units are what give us the data that we want. And then variables are those that, so since given the name variables, they are variable, they change, and they can be measured, and they can also take on different values there. So yeah, we have two different types of variables. We have categorical variables, which are, they have labels or groups. These are things like colors or brands of something, flavors of something. And then we have two different types of categorical variables, which are going to be nominal or ordinal. Nominal variables are going to be ones that don't have any sort of hierarchy, no sort of order to them. They can basically take any order. So those are things like flavors, for example. And then ordinal are going to be things that do have a hierarchy. So that's if we're getting into having, if we have like class standing, so like freshman, sophomore, junior, senior, that would be a ordinal categorical variable because it is a category, a label, but it does have a specific order to it. So that's where we get that from. And then we have quantitative variables. So these are going to be numbers with consistent intervals. These intervals are going to, you know, numbers are always going to have, you know, the same, they can go anywhere from whatever the max and min are. So they are going to have some sort of value to them. And we're going to have discrete and continuous quantitative variables. So discrete are going to be those that are, they can only take on a set number of values. So these are things if we're talking about having a variable that can only, for like people, for example, because you can't have like 1.5 people per se. And then continuous variables are going to be those that can take on any value in between the minimum and the maximum. So these are things like weight, height, any type of measurement such as that is going to be a type of variable there. All right. All right, so a little bit more on variables. So remember, these vary given the name, and we have two different types that we talk about in terms of what the difference in the explanation of your outcome is. So our explanatory variable, you see explanatory, explain, that's going to be explain the difference in our response variable. So our response variable is our outcome, what we get at the end of our study. And so that means since our explanatory variable is explain that outcome, it does have to be independent because we don't want that to be affected by anything else because then our final answer wouldn't really make sense. And then we have a response variable, which will be dependent because it's dependent on what the explanatory variable is. You know, if the explanatory variable is some sort, like since it's independent, it's not going to change. And then our response variable is going to change dependent on that, which is why it is dependent upon that explanatory variable. All right, so we do have independence and dependence. So just what we just talked about. So independence means they're unrelated. They don't get affected by one another. Dependent means that they do get affected by one another. And the main idea here is that for independence, things are independent if you're in a randomized experiment. If you make things random, that means that you're not going to really have bias, and you can assume, you know, that they are going to be independent, don't affect each other, so you can have a representative study and a representative sample there. If things are dependent, often we have pairs that are matched together. So if you think about, you know, if you have, if you're pairing together a person's midterm grade and a final grade, those usually are dependent on one another, assuming the fact that, you know, what they got on the midterm is going to, you know, affect what they got on the final in terms of like their studying habits or something like that. So that's why pair to match pairs are usually going to be our those that are dependent on one another. Like I said many times, the subjects in the same are the same in both groups. So that's like talking about one person and their midterm and final grade. That's a common example that we will use in this class here. Okay, so samples and populations, this is basically the main basis of statistics, because this is where we figure out, what we're trying to make an inference about and how we make that inference. So populations are going to be our entire population, everything that we're looking at. But often it is hard to get, data from an entire population, so that's why we have samples. So our population is fixed because it is whatever the amount, or so for example, like everyone in the United States, that technically, if you think about it, if you're taking a census, that's going to be fixed. Your population isn't changing per se. Your sample is going to be what we take from the population. So I always kind of draw this like a cycle. So you have our population and we take a sample from it. And then based upon this sample, we make an inference about our population. So this is something that I see every semester that students struggle with, is when we make our conclusions, when we get into like confidence intervals and hypothesis testing way down the road, just remember that any type of conclusion that you make is going to be about the population. So when you make a conclusion, you want to make it in terms of the population. You're not going to be talking about the sample or that kind of thing. You're using that sample to make an inference about the population, because what we find in the sample is what we find. We're not that's what we have. We don't have to make like a prediction about it, but we're using that sample to make an inference about our entire population there. So yeah, that's what samples are. And in comparison to populations, they are variable because we usually try to take random samples like I talked about before, so they're independent from one another and don't affect one another. So yeah, and like I've been saying, used to make inferences about our population, which is an important part to realize. Okay, so when we are taking samples, we have two different types of sampling methods that we can use. So simple random sampling is a preferred method because this is where we can find more representative samples that are independent from one another. And so it is probability based because it's kind of like the probability of you picking, if you had, like a jar of marbles and you had like 7 blue marbles, 3 green marbles, it's a 3 out of 10 probability that you get a green marble. So that's going to be simple random sampling because, you're taking a random sample of each of them, or you're taking it at random times. You're not picking them, in terms of, what you want to pick, because that would skew your data and make it unrepresentative. So you do want to have an equal chance of selection in order for it to be unbiased and for it to be representative there. So yeah, and that's going to be without replacement. Simple random sampling is you just keep taking samples from the population and you're not putting them back. You keep taking random samples from the experiment there. And then convenience sampling is not really a preferred method because it can lead to bias and confounding variables, which we'll talk about later. Convenience sampling is basically what you do if you don't have a lot of it's easy to do. If you don't have access to your population, if you only have access to a smaller group, and it's not as representative, this isn't random. You're basically taking what you have. So this isn't preferred because it may not account for the entire population, because the sample that you have, just because it's convenient, may not represent the entire population as a whole. So that's why we don't really prefer this method. Okay, so bias is obviously bad, shocking idea there. So we want to get a representative sample like I've been talking about. And for that, that means that it's going to represent the population. Because remember, we're using these samples to make inferences about the population. So what we find from the sample, if it's representative of the population, that's when we can make a confident inference about it. But in the case that we don't have proper sampling, so for example, if you use convenience sampling, that's when we could get sampling bias. So that's not going to give us a representative sample. So it could favor certain outcomes, and this is like bad sampling methods, like I talked about convenience sampling. And we'll talk about other ones, later on, where there's different, there's issues with how you ask the question and whatnot. But the main idea here is that you want to make sure you have a representative sample that doesn't interfere with the population and how you're representing it in any way. So, and just some examples then again about if you get sampling bias, one type of sampling bias is non-response bias. So let's say you put out a survey and it's about, what's your favorite type of story or something to read in the library. Well, if people are really passionate about that, people who go to the library all the time, those people are going to be the ones responding. And then the people who don't respond are going to be the ones who really don't care as much. So that's going to give you a sampling bias, because that's going to show you that the people who didn't respond aren't really part of that sample. They're not showing the entire population if you're looking at, the population of State College or something in that case. So that's the idea there. And this is an important point to make. Causation doesn't mean association. So if we find that, things are, well, if it's randomized, we can make some sort of causal conclusion there, but we can't, if we find out things are associated, you can't say that one causes the other one. We're just saying that they're associated with one another. We see some sort of relationship, but that doesn't mean that one causes the other one. If you find a relationship between, people who work out and, their hair color or something, if for some reason you found something to be there being a relationship and there's association with them, we can't say that someone's hair color, causes them to work out a certain amount. You can't make those sort of conclusions, because remember, these samples are just that. They're just samples, and they're supposed to be representative of our population, but we can't make, those strict conclusions about that in any way. Okay, so now talking about studies, so experimental and observational studies, these are just going to be the two different types that we do. So like I've been talking about, when you have a randomized experiment, that's what we prefer, because it's going to give you a more representative sample. So for experimental studies, we do manipulate something. The researcher does impose a treatment upon the subjects. So for example, giving them a certain medicine or changing the environment. Anything like that. We also call this a scientific study. So if you think about, in science, you're manipulating something, you're putting like chemicals in something. I don't know. I don't really do the science thing, but something like that. And if you do, like I said, a randomized experiment, then you can control for confounding variables and making sure that it is representative of the entire population if you do have an experiment it's randomized. And then if we have observational studies, that means that we're doing no manipulation. I often just say this is people watching. If you're just, chilling in the mall and looking at some stuff and some people, and you're trying to figure out, how many of these people have like purple hair, That's a horrible example. Now let's say that you're in the mall and you're trying to figure out how many people are wearing sneakers, okay? And you're just watching the people walk by, and you're, taking data on, how many people are wearing sneakers. That's an observational study. You're not, there's no sort of treatment going on. You're not, picking who has sneakers or not or anything like that. So the researcher does nothing. So just kind of sit back and relax there. And then this does run our risk of confounding variables, because there could be something that, since we didn't randomize anything or impose a treatment, there could be something that is, an underlying variable that's affecting the outcome that we have. For example, maybe where you were in the mall, you're sitting in front of a shoe store or something. So you see a lot of people, or like a sneaker store, something like that. So that can be a confounding variable. So it's not really showing you, the amount of people in the mall per se that have sneakers on, in comparison to everyone, because it's not really showing everybody in that case. All right, and then just one more thing about experimental studies. So remember, these are the ones where we do impose some sort of treatment. We do have two different ideas for experimental studies that are often talked about. So our control group is our baseline. That means that they don't receive any sort of treatment. They're just going to be the one that we're kind of comparing to. And then if we have a placebo group, that means that they're going to receive a fake treatment. So if you've heard of like placebo pills or something, that means that, they're kind of representing having an actual pill, but they're not going to have any effect upon the subject. So that's our placebo group. So that's just another idea here. It is a control group, but they're technically receiving a treatment, but it's fake. So technically they're not receiving treatment, if you think of it that way. And then blinding is just ensuring that we have validity. So, we want to make sure that it's valid, and it's going to show us, so reliability is saying it's consistent, but then, validity is saying that we think it's going to be, the same there. And if we have double blind and single blind, single blind means that the participants don't know the treatment group they're in, but double blind means that both the participants and the researcher don't know. So it's very randomized. And this would be if, there was a chance of having a researcher bias, if, the group, for example, like if there was a teacher and they were choosing the groups, they could maybe have some sort of bias with the groups that they picked, unintentionally or intentionally. So in that case, you would want to do double blind so that neither of them know what the assignments are, and there's no sort of bias in that case. Okay, cool. So, and like I said at the beginning, for anyone who wasn't here, for these reviews, as I just went through, the different topics that we talked about this week, and then we'll have some review questions at the end. You guys are more than welcome to, usually I just say, you to type your answer into the chat box. If you have any questions or anything, go ahead, feel free to use your microphone, your video, whatever floats your boat. And yeah, so we'll do those. And then at the end, I'll open up to any other questions, but we also have Q&As for you guys to ask those sort of questions. Usually people are pretty done with stat by the end of these ones. So, but like I said, any clarifying questions, you guys are more than welcome to ask. And yeah, so let's do some review questions here to finish up for tonight. This is a shorter chapter. These reviews will get longer. So get excited. Those are the best ones. So let's try these questions here. So our research question is, do 6-month-old babies who are being breastfed weigh more than 6-month-old babies who are not being breastfed? So we collected data from 10,000 6-month-old babies. Whether or not the baby was being breastfed was recorded, as well as the baby's weight in pounds. So which of the following statements is true about this study? So go ahead and read through these options A through D, and go ahead and participate and put your the answer you think it is into the chat box. And after a little bit, when you guys respond, we will go ahead and go over the question, and then you guys can ask questions about it. So go ahead and try this one out, and then we will go over it together. Okay, good. So, okay, no question marks after your answers. You need to be confident in the answer you choose. So either no question mark or an exclamation point. Confidence is key in statistics. So step 1, just kidding. No, I'm not kidding. Exclamation point. So let's look at this one. So yeah, and by the way, I try to put some tricky questions in here because this is the time to, try these out when you have someone to explain it to you and, to try it out and that kind of thing. So let's go through these options. So A, it says the study doesn't have a large enough sample size. That's pretty untrue because our N is 10,000. If you guys remember, N is the notation for a sample size. So that is large. So that's not right. B says the study lacks randomization. So this is actually our right answer because if you see, it just says that they took 10,000 6-month-old babies and recorded if they, their weight and if they're being breastfed or not. So this is observational because literally all they're doing is looking at these babies and being like, what's your weight? What's your food preference, So this is just very, there's no sort of randomization. They didn't randomize the baby and, decide who's being breastfed or whatever and this and that. That's not a thing. What is going on down here? Okay. Okay, so, but yeah, so then we have, so yeah, C says the group that is breastfed is the placebo group. That is not true, because remember, placebo means that they don't receive any sort of treatment, but in this case, since it's not an experimental study, we can't have a placebo group. This is only if we had an experimental study, so these are both untrue since it is an observational study there. So yeah, our answer is B. Does that make sense to everybody? And please don't tell me it makes sense if it doesn't make sense. I would like to help you guys. That's what I'm here for. So please let me know if you have any questions. I'm more than happy to go over it again. But yeah, and participate, guys. Let me know your answer. Say IDK if you don't know. Say IDC if you don't care. Just let me know. It's okay. And also let me know. Okay, if no one says anything, I'll just be like, okay, you guys understand. Just holla at me if you don't understand. I'll explain it. Clear. Boop. Okay. Next. Okay. So in the fall of 2015, there were a total of 508 undergraduate students enrolled at Penn State Shenango. Of these students, 204 were enrolled in an associate's degree program. So we have 40.2% of them. That's our, almost said the answer. That's what we got there. So 40.2% of all Penn State Shenango students were enrolled in an associate degrees program in fall of 2015. So which one of these following describes the value of 0.402? So let me know what you guys think the answer is for this one, and we will go over it together. All right, yay, thank you for participating. Good job. So let's think these things through. So remember, this is one thing that after this chapter, you guys will definitely understand this. It's a little tricky at first, but statistic never goes with population. So a statistic is a measurement of a sample. Okay, so this is an option because a sample statistic is a thing, and also a population parameter is a thing. But C and A can't be correct because there's no such thing as a sample parameter or a population statistic. That's just like, no bueno. So that's the thing. Remember, it's PP, and then it's SS for sample statistic. So yeah, so those are our two options here. And then in this case, we want to make sure that we choose, yes, check out that exclamation point. Wow, amazing. So, all right, so, and if we look at this, if we're talking about, so we have our population is going to be the 508 undergraduate students, okay? So that's going to be our population. And then from that, though, we took this 204. So remember, from our population, we take samples. So the 204 was our sample. So when we took that 204 divided by our population, so our sample divided by our population, we ended up getting this 40.2%. So that 40.2% is the sample statistic that we got from the entire population of all the students that were associated. So technically, we're saying that this is, representative of our population, but we're trying to figure out, because it says of all Penn State Shenango students. So in that case, that's going to be our sample statistic there because we're taking it from our population. That's our sample statistic. because we're making inference there. So does that make sense to everybody in the club? If anyone's sad today, here's a smiley face to brighten your day. Okay. Yay. And like I said, let me know if it doesn't make sense. I'm more than happy to go over it. Okay, yay. Boop, boop, boop. Clear. Bop, boop. Oh, yeah, sure. Boop. Yes, thank you for asking. So remember, our no, don't apologize. That's what I'm saying. Please ask questions. You guys, that's going to help you get through this course. And, historically, the people who have come to these sessions, participate and everything are the ones who do very well. So come hang out. But okay, so remember, we have our population. Our population parameter is going to be, what we have. So this is our population technically. Well, this is what we had. Like that's the total of whatever the Penn State students enrolled there. But then we're trying to figure out, so this is saying all Penn State Shenango students were enrolled in the associate degrees program, but we're taking this 40.2% because that's the sample that we got. We took this sample from all the Penn State students to get the 40.2. So that's the sample that we ended up getting. It's not showing us the population of like all Penn State students or anything. But it's showing us just a sample of the ones from Penn State Shenango. This is just showing us a sample from them, taking that 204, that was going to be our sample. That's the 204 that were enrolled in that. So that's like part of it. So it's our sample, because remember, we take samples from the population. Does that make sense? You're very welcome. Thank you for asking. Woo, woo. All right. You're very welcome. You guys are so nice. Yay. Okay, so another one. Yay. All right, a school psychologist wants to use students' intelligence test scores to predict their reading comprehension scores. She takes a sample of 100 students and records each individual's intelligence test and reading comprehension scores. In this scenario, what is the response variable here? So read through these. Let me know what you think. That's bothering me that there's not a space between C and D. Please ignore that. And we will go over it together. Okay, yes, books are important. Definitely order the book. But no, it's okay. You can definitely, and like I record these, so you guys can, pop on over to the YouTube channel. I'll tell you about that at the end, but grab some popcorn, rewatch this, enjoy me talking about statistics. Ooh, a trial period. Interesting. Try before you buy. But yeah. Okay, so let's go through these. So we're looking for a response variable. So remember, this is going to be dependent. So this is going to be, our outcome variable. So if we look at our answer is going to be C here, because the reading comprehension scores are dependent upon the intelligence test scores, because they're trying to see if the intelligence test scores, are going to be predicting the reading comprehension scores. So if you ever see, a statement like this, whatever's saying, if something is predicting something else, that means that, this is going to be our explanatory, and then our whatever it's predicting is going to be our response. So as you can see here, that means that this is going to be our explanatory variable. And then, so that's not our answer. And then 100 students are participated. This is going to be our sample size, actually, so that's not right. And then the relationship between the scores, that's not a variable, that's a relationship. A variable is just one thing. So that's why C would be our reading comprehension score. So that's going to be dependent upon our explanatory variable, which is the intelligence test score. So dependent on what our intelligence test scores are, that's going to tell us what our outcome of the reading comprehension scores are. Does that make sense to everyone? Boop, boop, boop. Yay. Raise the roof. I'm loving the exclamation points, or lack thereof. I'm loving the lack of the question marks. Confidence. Bob. All right. Okay, one more, yay. So research question, can the age of a child in months be used to predict his or her vocabulary? So that's what we're trying to figure out. So data were collected from a sample of 500, ranging in age from 12 months to 60 months. I never understand why people describe children like that. Like, just call them 3 years old. I don't. Side note. Okay, so what is the explanatory variable here? So read through these answers, or these options, and let me know what you think the answer is. And we'll go over it. Laura's on the ball. Check it out. Woohoo! Amazing. Geniuses. So yeah, our answer is A here. A for Anne-Marie, obviously. Just kidding. Okay. So our age in months is our explanatory variable, because our age is, remember, like I said, if you see predict, you're going to assume that, our explanatory variable is going to be before that, and then our response is going to be after. So that's why our age in months is going to be our explanatory. And then, so B isn't correct because this is our sample size. So that's not correct. Not sure what that was. Vocabulary is our response variable. That's why that's not correct, because our vocabulary is dependent on our explanatory variable. Yes, yay is correct. Amen. And then D is not correct because the range of ages, that's not a variable there, so that's not correct either. So our answer is A. So, woo, great job. A plus, raise the roof. Any questions on that one? You guys definitely seem to have a hang of that. the more and more you practice these things, the more they'll come to you. My biggest suggestion for this class is that you stay up on it. It's one of those ones that you cannot wait around to study for. Unfortunately, if you're a procrastinator, you better don't do that. So, because everything builds on it. You'll see as we go through the semester, you know, everything builds on the chapter before. You know, nothing we do is really random. So definitely be thinking about that. So, all right, cool. Good job, everyone. All right, so that's the end. The end, sad. So like I said, you can go ahead and find recordings of the group reviews that I do every week on Thursdays on my YouTube channel. Super fun. I'm going viral. It's amazing, you know, getting all those subscribers. And our next, oh, and that link is also on the Review Session Central page on the notes website for Stat 200. And then our next group review will be on Sunday, and Lydia is going to be leading that. That's another one of our tutors that's starting this semester, so she's going to take over one of the reviews that I used to do, so she's going to do our Sunday reviews. And then if you haven't done already, please go ahead and put your Penn State email into the chat box. I will not email you, I promise. Unless you want me to, I'll say hi. But we just use it for attendance purposes so we can have these free sessions and whatnot. So yeah, if you have any other questions for me, please go ahead and put them in the chat box. If not, you guys are good to go for tonight. I hope you guys have a good weekend.